Good morning, everyone. So I am back. I am Bambi at your service. So for this week 2 of quarter 2, allow me to present to you my lesson about the circle. So these are some examples of circle and its application. I remember this movie. This movie entitled Circle is very thrilling and so many suspense. Okay, masyado siyang masuspense ng movie na to. I love this one. So again, I am going to present to you about circles and other related terms. So objectives of this week's lesson are as follows. First, understand the parts of a circle. Second, derive inductively the relations among chords, arcs, central angles, and inscribed angles. And third, find the measure of angles, arcs, and intercepted arcs of a circle. So when we say circle, it is a set of points on a given plane which is equidistant from a fixed point called the center. So in your learning task 1, you're asked to give the following using the figure at the left. So did you able to answer this part? So you check your own work and let's find out if you got this correctly. So these are the answers. Okay, that's it. Did you get 10? Okay, so not exactly 10. Oh, so therefore, let us explore more about the different parts of a circle. So here, since we are in the world of geometry, you will be encountering different terms and their symbols. So we must use three symbols to represent them clearly and to differentiate one from the other. For a point, we use a capital letter. For a line, we draw this line on top of two capital letters. Same with segment, we do this one on top of two capital letters. Then we have an arc here. And then obviously you know the symbol for angle already, isn't it? So it is best to use these symbols to represent these terms. No symbol wrong. So these are the different parts of the circle. So we have the center, the radius, the diameter, the circumference, the chord, the tangent, the arc, the sector, and the segment. So this sounds interesting, isn't it? So let's explore this more. So let's begin with this figure. So there is a center B. Therefore, this circle that is named through its center will be called a circle B, since B is the center. And the symbol for this is yan. Next. Right. So here we have the distance around the circle, which is the circumference. Then there's another segment here, which is called the diameter. So diameter is the distance from one side to the other passing through the center of the circle. So it should pass the center of the circle. So in this figure, the diameter is line segment DC or vice versa, line segment CD. Another segment is this one. This is a radius. And a radius is a line connecting the center of the circle to the circumference. And this radius is called line segment BC or line segment CB. There's another radius here, and since there are more than there are two radius now, we call this as radii, which is the plural form of radius. So this segment is segment BG. Another segment here is a chord. A chord is a line touching the circumference of the circle at 2 points. So this is line segment DF or line segment FD. Now, my question is, do you think that a diameter is also a chord? Yes, a diameter is also a chord because it touches the circumference of the circle at 2 points. But do you think that a chord is always a diameter? No, not exactly. Just like in our example here, this is just a chord and not a diameter. Next, this is an arc. So when we say arc, this is the part of the circumference at the edge of a sector or a part bound on the circle. So this is bound on the circumference of the circle. So this arc is called arc DC or vice versa, arc CD. So we can see many arcs here in the figure like arc DG, arc FG, arc DGF, or arc CHF. Yeah, so arc CHF. So we can use 2 or 3 letters to name an arc. So the letters must be, just like in using 3 letters, they must be consecutive in order. And you can name the arc in either clockwise or counterclockwise directions. Now there are 3 kinds of arc. We have here arc AB, which is a minor arc. And we use 2 or 3 letters to name a minor arc. Minor arc measures less than 180 degrees. On the other side is arc ACB, which is a major arc. And always we use 3 letters to name a major arc. And this measures greater than 180 degrees. So what is that arc that measures exactly 180 degrees? That is a semicircle. In this figure, we have arc EDF and the other side is arc ECF. So you see, my dear students, a circle consists of 2 semicircles. Therefore, one complete revolution of a circle is equal to 360 degrees. Next, this shaded region is called the sector. So this is the part of a circle between 2 radii and an arc. And you see the 2 radii and then the arc. So this is called sector DBC. Now, there are 2 kinds of angles in a circle. This one is a central angle. It is an angle whose vertex is at the center. So you see that center is at point O, which is also the vertex of the angle. Therefore, angle SON is a central angle. Whereas this one is an inscribed angle because its vertex is on the circle and the other 2 points are on the circumference of the circle. So you see, points S and M are on the circle as well as its vertex. So that's the difference between the central angle and inscribed angle. Next, you see that there's another shaded region here. And this time it is called a segment. So when we say segment, segment PTN and segment NTP, this refers to the part of a circle between a chord and an arc. Yan. So there are 2 shaded regions that you see on a circle. The first one that I presented was a sector. It is a region bounded by two radii and an arc. This time, for a segment, it is a region bounded by a chord and an arc. So that makes the difference between the two. Now, you see also two kinds of lines in a circle. Now, this one is a secant. So, secant line QM or line MQ. And this is a line which touches a circle at 2 points. So, you see that this line crosses the circle at points Q and M. Whereas this line, which is a tangent, line SR or line RS, touches a circle at 1 point only, which is point R in this example. And we say that point R is the point of tangency. That makes the difference between the two. Secant passes the circle at 2 points. Tangent passes the circle at 1 point only. And so these are the different parts of a circle and their representations. Moving on, let's see the relations between chords, arcs, central angles, and inscribed angles with respect to their measures. Let's begin with the central angle and their intercepted arc. So you know what a central angle is. And this time, it says that the measure of a central angle of a circle is equal to the measure of its intercepted arc. When we say intercepted arc, it is formed when one or two different chords or line segments cut across a circle and meet at a common vertex. So in this figure, we have two different chords here or line segments that meet at a common vertex, which is point E. So this is an angle with its intercepted arc. So it says that the measure of angle BEA is equal to the measure of arc AB. Yan, so they are equal. So assuming that angle BEA is 100 degrees, it goes that measure of arc AB is also 100 degrees. So they are equal. So that's the relationship of the central angle and its intercepted arc. Now, for the arc addition postulate, it says that the measure of the arc formed by two adjacent arcs is the sum of the measure of the two arcs. So, when we say adjacent arcs, they have the same side. Yan. Found on the same side. So, look at this. We have adjacent arcs here. So, that's arc AB and arc BC. So, it goes that their sum is equal to measure of arc ABC. So, yan siya. Suppose that measure of arc ABC is 120 degrees and measure of arc AB 70 degrees. Then the measure of arc BC is equal to 50 degrees. Yan. So, just simply add them. Another example, so we have the measure of arc BTL is equal to the measure of arc BT plus the measure of arc TL. Assuming that these are the values, so we say that 160 plus 130 is equal to 290 degrees. One more example, so you complete this one. So measure of arc CAB is equal to the measure of arc CA plus measure of arc AB. So that will become, so just in case we're given the values of the two arcs, we can find the missing values by subtracting them. Okay. Next, how about the relationship of inscribed angle and its intercepted arc? So when we say inscribed angle, as I have said, its vertex is on the circle as well as its 2 points. And It says that the measure of inscribed angle is equal to 1/2 of intercepted arc. So it's 1/2 of intercepted arc. So this is the intercepted arc. And suppose that the inscribed angle is 80 degrees. So this is the inscribed angle. And the arc must be twice as big as the angle. Therefore, 80 times 2 is 160 degrees. So if the unknown is the the intercepted arc, you multiply the inscribed angle. If the unknown is the inscribed angle and given is the intercepted arc, you divide it by 2. So moving on, find the value of x and y. So angle x is a central angle. Angle y is an inscribed angle. We have the measure of the intercepted arc of both angles. So first, let's get the measure of angle x, which is a central angle. So they must be equal to 120 degrees. So in short, measure of angle x is 120. And measure of angle y is 60 because 1/2 of 120 is equal to 60. Angle y is an inscribed angle. So we need to get 1/2 of 120 degrees. So you see the difference between the two angles. Moving on, let's have more example. Angle PEO is 80 degrees. So therefore, the intercepted arc is also 80 degrees. Now, what's the measure of angle PHO, which is an inscribed angle? So obviously, it is equal to 40 degrees. Now, let's have this. So we have given arc, the measure of arc MN is 120 degrees, and then the measure of arc MQ is 100 degrees. So MP is a diameter. Now we need to find the following. So I advise you to complete the details first in the figure before you proceed to the question. So let's begin with this one. So since this is a MP is a diameter, so we have a clue on what becomes the measure of these arcs, diba? So we simply subtract it to 180. So therefore, this is 80 degrees. 180 minus 100 is 80. And this one will be 60 degrees. Now, this is a right angle. And you know that a right angle measures 90 degrees. Yan. So meron na tayo. Next, we can either get the measure of this angle, which is an inscribed angle. So we get half of 80 is 40. And then we can get this. So angle P is also an inscribed angle. So we get half of 100. So that is 50. Or also we can apply the theorems about the angles in a triangle. Diba? Remember that in grade 9? Sabi nila ay, ang sabi do sa theorem is the sum of the measures of the angles of a triangle is equal to 180 degrees. Bumaba yung aking mga symbol ng degree. And then one more here. This is a central angle. So its measure is also 60. O ngayon, narito na sagot. So the measure of arc QP is 80. The measure of arc PN, nasa ng PN? Ito, 60. The measure of angle MQP, ito. So that's 90. The measure of angle MPQ, so yun ay 50. And then the measure of angle PON is 60 kasi siya ay central angle. Ito yung kanyang intercepted arc. Yan. So, ganyan ang pagsagot ng ganyang klaseng tanong. And one more example. So, triangle TRY is inscribed in circle I. If measure of arc TY is 112 degrees, find the following. So this triangle inscribed in circle I is an isosceles triangle based on the markings that is represented here. So meaning to say the sides, these two sides are equal. So let's complete first the facts in the figure. So given is RTY, which is 112 degrees. So this is 112 degrees. This is an inscribed angle. So half of 112 is 56 degrees. Yan. And then we will get the measure of these arcs. We know that one complete revolution is 360. So subtract 112 and then divided by 2 is 124. Bakit by 2? Because they are two equal sides. So it goes that this arc is equal to 124 degrees as well as this one. And since this is intercepted arc of angle y, which is an inscribed angle, so we get half of 124. The same with this one. So 62 rin siya. And also remember the theorem about the isosceles triangle. It says that the base angles of an isosceles triangles are equal. Okay, so it's complete. So we can now proceed in answering the questions. So measure of angle TRY. Where is it? TRY. So it's 56 degrees. Measure of angle RYT. So that's 62 degrees. Measure of angle RTY. So that's 62 degrees. Measure of arc RT is 124 and measure of arc RY is also 124. Okay, so that's how to answer this type of problem, which is similar in your written work number 2. So try this. Are the measures of central angle and scribe angle with the same intercepted arc equal? The answer is no. One is equal to the other one is half. Diba? This one. True or false, two intersecting chords on the circle form an inscribed angle? Yes, it's true because it formed, you see this one, it formed an inscribed angle. These are the two intersecting chords. Two intersecting diameters intersect at the center. Agree or disagree? Agree. Because diameters always passes through the center, so naturally, their intersection is the center. This one is the measure of an inscribed angle twice the measure of its intercepted arc. The answer is no. It's not twice, but half the measure of its intercepted arc. And so for your performance task number 2, you're going to look for the center of the circle and label it as point C. Then from that, you name the two congruent triangles and you answer which is the best seat in watching TV. Is it an angle C or angle F and Y? Okay, so the end of my presentation. So thank you for listening, everybody. Have a nice day and always keep safe. Bye-bye. Love you all.